And this is our next question. The question states that there is a polygon, and I know a polygon is a figure which is n-sided. So that means it is just a figure in mathematics that can have a particular number of sides. You can be able to think of a triangle that has 3 sides, triangle, 3 sides. You can think of a rectangle that has 4 sides. You can be able to come up with what you call a square that has as well 4 sides. You have what you call a parallelogram that still has 4 sides, and a rhombus that also has 4 sides. And of course, these 4 are referred to as quadrilaterals. So this is a triangle, a 3-sided figure. A rectangle, a square, a rhombus, and a parallelogram are all referred to as quadrilateral. From the word quarter, that means they are actually 4-sided. And you are told that this is a polygon whose name is not provided in the question we are having here. Has 4 given interior angles, and the first interior angle is 130 degrees. The other interior angle is 135 degrees, and the other one is 160 degrees. And they're telling us that the rest are each 145 degrees. So we're told to get the number of sides and as well the sum of the interior angles of this polygon. So, and the question was given us 5 marks. So we are then supposed to just make a sketch of this parallelogram if it is a 4-sided figure, or a polygon if it has more than 4 sides. You can talk about a pentagon with 5 sides, a hexagon with 6 sides, a heptagon with 7 sides, an octagon that has 8 sides. We have what we call a nonagon with 9 sides, and a decagon with 10 sides. You can be able to have what we call an undecagon, or a dodecagon, or a tridecagon, or a tetradecagon, or a pentadecagon, based on what you're actually giving as the number of sides. So if I decide to use this as my just drawn sketch, and I indicate here an interior angle of 130 degrees, I can come back here and indicate an interior angle of 135 degrees. I can have another interior angle here of 160 degrees, and the last interior here is what I have as an interior with 145 degrees, and we are told that the rest are each 145. So I can't exactly tell how many do I have in terms of the ones that have 145 degrees in terms of the interior angles of this polygon. So then the question is that you need to get the number of sides. So we do not exactly know how many 145 degrees interior angles do we have in this polygon. They can even be 10 or 20 or even 1,000. So then you're supposed to form what you call an algebraic equation for this for us to get the answer. So we need first to actually use that concept of the exterior angles, because for the sake of the interior angles, we can't be able to do anything here, not knowing the number of 145 degrees interior angles. So the assumption is that we must just get a particular sum in terms of the exterior angles, which remains constant for all polygons. So this will now be able to give us 45 degrees. So if the interior is 135, the exterior is 45, to mean that the sum of interior angles, and of course that get obtained by a particular formula, will be different from the sum of the exterior angles, which can still get obtained by a particular formula. So angles lying on a straight line add up to 180. So if the interior is 135, the exterior is 45. Then if the interior is 130, the exterior will be 50 degrees. If the interior is 160, the exterior is 20. And if the interior is 145, the exterior is 35. But how many 35s do we have? That is not what we actually have. Then I'll just come here and say all the interior angles are not known, but the exterior angles should add up to 360. So the first exterior angle is 45 degrees. It is here, you can see it, if the interior is 135. The second is 50 if the interior is 130. The third is 20 if its exterior is 160. And of course, angles that add up to 180 degrees are called supplementary angles. So supplemented angles are able to add up to 180. They must lie on a straight line, that is. So then next is 35. But we do not know how many 35s we have, because we have this 35, we have another 35 here, and other 35 degrees as exterior angles. So I can say 35 degrees 1, but you can have x of them, which are not known to us. Then this must add up to 360 degrees, because the sum of exterior angles for any polygon should add up to 360. Wow. Be it a triangle, a parallelogram, a pentagon, a hexagon, a heptagon, a decagon, a nonagon, an octagon, or a rhombus, or a square, or any quadrilateral, they must add up to 360 degrees. So let me see what I'm going to get as the answer. So 50, 45, 20, those are known as each one exterior angle. But these other 35 degrees exterior angles are not known in terms of number. So we shall say 1 is 35 then times x. So let's come back here. So 45 plus 50 plus 20, that is 70. 70 plus 45, that is 115. 70 plus 45, that is 115. Wow, so then plus 35x. Where am I getting x? I know I have also another exterior angle which is 35, but I don't know how many there are, because we are told that there are several 145 degrees interior. So for the several 145 degrees interior angles, we should be able to have several corresponding 35 degrees exterior angles. We are saying that let that number represent x. This must add up to 360 degrees. So I'll just collect like terms. I'll take this on the other side of the equal sign, so that I'm going to have 35 degrees should be equal to 360 degrees minus 115 degrees. So that 35x is equal to, so is it going to be, let me see, so that's 360 minus 115. So this is 5, that is 5, that is 4, that is going to be 245. So 35x is equals to 245 degrees. So divided by 35, divided by 35. Let's see. So this and this will disappear. So x. So I'm going to have 5 there is 7, 5 there is 4, which is 20. Then 45, 9. Then 7 into 49 is 7. So x is 7. So the 145 degrees interior angles are 7. That is to say, there are 7 35 degrees exterior angles. So 7 plus those 3, we shall have the exact number of sides for this polygon. So 7 plus 1, 2, 3. So this polygon has 10 sides. This polygon has 10 sides. The 35 degrees exterior angles are 7. Plus this 50 plus that 45 plus 20, it gives us 10 sides for this polygon. So how do you get the sum of interior angles? You can either say n minus 2 into 180. You can get the sum, or someone else can say 2n minus 4 into 90. That still gives you the sum of the interior angles of this polygon. Let me come back to the first formula for that matter. So I'll be able to have n. N represents the number of sides. How many are they? There are 10 sides for this polygon. So 10 minus 2 into 180. I'll be able to get the sum. So that 10 minus 2, that is 8. 180 multiplied by 8. So 0, 4, that is 1440. So you'll be able to have a sum of 1440 degrees Celsius. If you're talking about temperature, but for the case of these angles, you can be able to say 1440 degrees as the sum of the interior angles of this great polygon. That is what you need to get as the answer, and that is what the examiner expected you to give as a student in that examination that you did, if you're to get the sum of interior angles of this polygon getting talked about in terms of this question.